welcome you all. My name is Dr. Tarun Sharma. I am HOD Department of Science. Today I am going to discuss about the topic partial differentiation. What is partial differentiation and what is their basic applications? So first of all, let us consider y is equal to f of x be the defined function in single variable. In single variable where y is the dependent variable and x is the independent variable. Then from the definition we know that dy by dx is equal to limit small del x tends to 0 f of x plus del x minus f of x upon del x. This is number 1 from the definition of continuity. But if we have u is a function of x of y, f of xy, that is it is a function of two variables where u is the dependent variable and x and y be the independent variables, then we know that del u by del x is equal to f of x is equal to del f by del x f of x plus del xy minus f of xy upon del of x. Similarly, del u by del y is equal to f of y del f by del y is equal to f of x y plus del y minus xy upon del y. Basically here del u by del x, f of x and del f by del x is the representation of first order partial differential equation. While solving the partial differential equation, we know that function must have more than one independent variable. Then we differentiate with respect to one independent variable and keep other variable as a constant. Therefore, while differentiating this function partially u is equal to f of xy with respect to x, we denote this function as del u by del x is equal to f of x or del f by del x. Here del u by del x and del f by del x are same. We can write this and this. This is the notation of first order differential equation of any function. Here u is the function in f of xy. In the general definition of del u by del x is given by relation 1. Similarly, when we differentiate partially the function, this function u is equal to f of xy with respect to y, then we have del u by del y f of y del f by del y, and the mathematical notation is given by relation 2. It is basically general definition of partial differential equation. For higher order partial order differential equation, we have here we found that del u by del x f of x del f by del x is nothing, it is f of x plus del xy minus f of xy upon del of x. This is one. And del u by del y f of y del f by del y is equal to f of x y plus del y minus का f of xy upon del y. This is number 2. It is basic general definition of partial differential equation. Again from 1, f double x is equal to del 2 f by del x square is equal to del 2 u by del x square. It is we can say that, or it can be written as del by del x del f by del x, or del by del x del u by del x. This is nothing, this is second derivative of del 2 f by del x square, and this is second derivative of del 2 u by del x square. Basically it is a representation of second derivative of function f of xy with respect to x. And again from 2, f of double y or del 2 f by del y square del 2 u by del y square is equal to del by del y del f by del y is nothing, it is del 2 f by del y square. And similarly del by del y is del u by del y is nothing, second derivative of del 2 u by del y square. And also we have f of xy del 2 u by del x del y, or del 2 f by del x del y. And f of yx del 2 u by del y del x is equal to del 2 f by del y del x. Basically these are the representation of any differentiation of partial differentiation of any function in second order term. Here f of xy is equal to f of yx, because u is equal to function xy is defined and continuous, defined and continuous function. So basically this one and this these all are the representation of any partial differential equation. When we differentiate partial differential equation in first time, that is first derivative of any function, then it is denoted by del f del u by del x. This is f of x or del f by del x. Similarly differentiation of that function with respect to y is denoted by del u by del y, f of y or del f by del y. When we again differentiate this function with when we again differentiate the function 1 with respect to x, then it is a second derivative of function f of x or derivative of f of x, and it is given by f double x, or in mathematical notation it is written as del 2 by del x square or del 2u by del x square. These all are the representation of second derivative of relation 1. Similarly, when we differentiate this relation partially this relation 2 with respect to y, then we found that f of double y del 2 f by del y square or del 2u by del y square. This is nothing, this can be written as like this. Basically here we noted that del by del x del by del y all are operators, and basically these operators are known as partial differential operator. As you know that for the total derivative or for the ordinary differential equation we have d by dx, but in partial we have del by del x. Basically it is different between both the operators. This is denoted by ordinary differential equation and this is for partial differential equation. In ordinary differential equation we differentiate the function, any given defined function, with respect to any one variable, because in the ordinary differential equation we have only one independent variable, but when we discuss about the partial differential equation we have more than one independent variable. Therefore partial differential equation has many variables and many derivatives, and these all are represented by as their formula. Now next we will solve how to deal with some basic function and how to find the first derivative, second derivative, higher derivative any defined function. Let us suppose u is a function of x square plus y square and find del u by del x, del u by del y, second derivative of and del 2u by del y square. Now we will discuss how we deal this function and how we find first derivative and second derivative of given function. For the solution of this we write as we are given u is equal to x square plus y square. We can say that it is in a function in two variable. It is a function in two variable. Now differentiating one partially with respect to x we get. So we know that how we will deal del u by del x. We will apply the operator in both the side, then we find that del u by del x, and here del by del x, x square plus y square. This operator and this derivative can be written as f of x del u by del x is equal to del by del x, x square plus del by del x, y square, and this is nothing, this is f of x del u by del x, and this will become 2 of x plus. Here we see that y is the other variable, and we know that while applying the partial differential property, when we differentiate the function with respect to one variable, then second variable treated as a constant, and we know that the derivative of constant function is always 0. Therefore this will become 0 and it is 2x plus 0. Therefore f of x is nothing, del u by del x, this is 2 of x. This is f of x is del u by del x is equal to 2 of x. So then we will write here for the further calculation f of x del u by del x, this is 2 of x. While applying the same approach, we will find the second derivative del u by del y, that is differentiating the given function with respect to y. Now differentiating one partially with respect to y, then we have del u by del y, this is f of y is equal to del square plus y square, and this is nothing, this is f of y is equal to del u by del y, and by applying u plus v formula we have and this is become 0 because x is the other variable which will be treated as a constant, and we know the derivative of constant function is 0 always. Therefore 0 plus, and this will become 2y. Hence we have f of y del u by del y is nothing, it is 2 of y. So we will put here f of y del u by del y is nothing 2 of y. Thus we have obtained del u by del x and del u by del y. Now we need to find that del 2u by del x square. So again from 1 u is equal to x square plus y square. This is 1. U is a function in two variable x and y. Now differentiating 1 partially with respect to x. When we differentiate del u by del x, when we differentiate this function partially with respect to x, we obtain that nothing 2 of x. Thus we have f of x del u by del x 2 of x, which is already obtained in earlier calculation. Now we will give this number 2. Now what is the calculation now? Now we differentiate again this function 2, this derivative 2 with respect to x, then we obtain del 2u by del x square, or we can say that while differentiating this function, or we can say while differentiating this first derivative again with respect to x, we obtain the second derivative of function f, or we can say that we can get del 2u by del x square. Now differentiating 2 partially with respect to x, we get, therefore del by del x del u by del x. Applying the operator both side, we get that this is nothing, this is f of double x or del 2u by del x square, this is 2. Hence we have f of double x del 2u by del x square is 2. So it is very easy to find the second derivative, but for finding the second derivative we must require first derivative of given function. Similarly we can approach for finding the derivative of 2, derivative of 1 with respect to y, and again secondly we differentiate that function, then we can find the second derivative of that function with respect to y. Now for obtain the second derivative of function u, that is to obtain the function del 2u by del y square, derivative del 2u by del y square, we will calculate from the relation 1 as differentiating 1 partially with respect to y. We know that del u by del y is nothing, it is del by del y x square plus y square, and it is 2y, which is already obtained. F of y del u by del y is equal to 2 of y, which is already obtained. This is number 3rd. We have obtained already actually, but now we are solving from starting so that we don't student don't have any kind of confusion for solving the second derivative. Now differentiating third partially with respect to y, we get and applying the operator both side, we get, and this is nothing, this is del 2u by del y square, and it is 2. Then we find that the second derivative is nothing, it is a constant which is 2. Therefore we have f of double y or del 2u by del y square is nothing, it is constant 2. Thus we have already we have obtained all the derivatives. This is first derivative with respect to x, first derivative with respect to y, and the second derivative f of x is f of xx, that is del 2 by del x square, which is a constant. Similarly, second derivative of f of y is f double y or del 2 by del y square, which is also a constant. Suppose that we are asked to find f of xy and f of yx, or we are asked to obtain f of xy and f of yx. Then we start as, since we have f of x del u by del x is equal to 2 of x, then differentiating this, we can give this number as a 4, differentiating 4 partially with respect to y, we get del by del y del u by del x del by del y, this is 2x, and this is f of yx, this is del 2u by del y del x, and this is 0, because here we have 2x but we are partially differentiating with respect to y, therefore the derivative of this function will become 0. Therefore f of yx or del 2u by del y del x would become also 0. So we can put here f of yx del 2u by del y del is equal to 0. Similarly, we can find f of xy. For this we have f of y del u by del y, this is 2 of y, let it is relation fifth. Now differentiating 5 partially with respect to x, we get del by del x del u by del y, and this is del by del x 2y, and this is nothing, this is f of xy, or we can write say del 2u by del x del y, it has become 0. Thus we can say that this derivative of f of xy of the given function is 5 is 0. Thus we have f of xy del 2u by del x del y equal to 0. Thus all the possible derivative of the given function has been obtained by taking the suitable example u is equal to x square plus y square. Here what we have observed, here we observed that we already stated that when u is a function of x of y be the defined continuous function, then f of xy is equal to f of yx. In our present case, in our present case we have f of xy del to u by del x del y equal to 0 and f of yx del to u by del y del is equal to 0. Hence here we observe that f of xy f of y is equal to 0. Hence it can be proved for all the function by solving this kind of methodology. Thus we have obtained all the function, all the derivative of given function u is equal to x square plus y square. So we can say that a solution of any partial differential equation is very easy. We should know how to handle and how to tackle the dependent and independent variable. Actually, student might have confusion about the dependent and independent variable. Basically, we have two kind of variables. Dependent variable and independent variable. Let us suppose volume of circular cone is given by v is equal to 1 by 3 pi r square h, where r is the radius of the base, h is the height. What we observe here? We observe that volume of any circular cone, that is V, is always depend between two variables. One is R and second is H. Thus we can say that volume of circular cone depends upon R and H. Thus we can say that it is the best example of two variable. Similarly, equation of PV is equal to RT, or we can say P is equal to RT upon V. Also suitable example of two variables. Here T is the absolute temperature, V is the volume, P is the pressure of gases. It is a standard equation which can be written like this. So we can say the pressure depends upon temperature and volume of the equations. R is the constant. Thus we can say that partial differential equation always involve at least two or more than two independent variable. Having one independent variable will always give us an ordinary differential equation. So it is the best example. Or similarly we can take another example for better understanding how to solve partial differential equation. Let us take u is a function of x square y plus y square x. Then find del x del u by del y. So how we will start? We will start like this. We are given u is equal to x square y plus y square x. This is number 1. It is clear that u is a function in two variable x and y. Here u is a dependent variable which depends upon two independent variable x and y. So differentiating one partially with respect to x, we get f of x del u by del x or del by del x x square y plus y square x, or we can write this x square y plus del by del x y square x. Similarly, the derivative of this function will be 2xy plus it would be y square. derivative of x become 1. Therefore f of x nothing, it is 2xy plus y square. So we write here f of x is equal to 2xy plus y square. Similarly, we can find the derivative of u with respect to y. So we can say that differentiating one partially with respect to y, we get del u by del y, del by del y, and the function complete x square y plus y square x. It is f of y, and this can be written like this. And partial differentiation of this will become x square, because x square is a constant, therefore it will remain same, and derivative of y will become 1, therefore, and it will become 2yx. Therefore f of y is nothing, it is x square plus 2yx, or we can write this 2xy. Thus f of y is equal to 2xy plus x square. So student, you know that it is very easy to find the differentiation of partial differentiation of any given function with respect to one variable while keeping the other variable as a constant. Here we are dealing only two independent variable, but suppose that we have more than two independent variable, then we will keep those those variable as a constant, and we will differentiate partially with respect to only asked, or with respect to only as we have asked the independent variable. Sorry. Now it is easy to find the second derivative of f of x and second derivative f of y. Let us take we have f of x 2xy plus y square. This is number third. Now differentiating third partially with respect to x, we have f of x, or del to u by del x square. We have del by del x 2xy plus y square. So we have del by del x 2xy plus del by del x y square, or we can write this here 2 is a constant and y is also constant, then we can take 2y at the outside and del by del x, and this is x, and this is del by del x, this is y square. So we say that 2y, and the differentiation of x is 1, that is 1 plus, and partial differentiation of y is 0. Thus we have f of double x, or we can say the second derivative of u, that is del to u by del x square, is nothing, it is 2y. Thus we have f of x is 2y. Similarly, we can find the second derivative of f of y. Now again we have f of y 2xy plus x square. This is number 4. Now differentiating for partially with respect to y, we have f of double y, or del to u by del y square, del by del y, this is 2xy plus x square, and it will become here 2 and x is a constant, therefore 2x is outside, del by del y, this is y plus del by del y, and this is x square. like previous way, it will become 2x into 1 plus this will become 0. Therefore, the second derivative of f, that is f double y, is nothing, it is del to u by del y square, and it is 2x. Therefore, f of y is nothing, it is 2x. Hence, we can find all the derivative as per requirement: f of x, f of y, f of double x, and f of double y. It is a second derivative. It is second derivative of f of x, and f double y or del to u by del y square is the second derivative of f of y. Similarly, we can find f of xy and f of yx as per our requirement. So we have noticed that if we have a knowledge about the dependent and dependent variable, then it is very easy to find the partial differentiation of any kind of function. But must noted that the function must be a continuous and defined function. In this lecture, we will cover only this kind of few questions. Please like, subscribe our YouTube channel Guru KPO, and don't forget to share this video. And in the next lecture, we will discuss some complicated problem of partial differential equations. We will deal that kind of problem which is asked in the examination. How we will solve that question, it will be seen in the next video lecture. Thank you for watching this video lecture.